The NEMA configurations have changed since that receptacle was manufactured. The receptacle is an old NEMA 10-15R duplex receptacle. It was commonly used in the early 20th century, before grounding became standard. The two sideways T-shaped slots are for the hot and neutral blades of a two-prong plug. The smaller T slot is for the neutral blade, which is typically narrower than the hot blade. This receptacle accepts two-prong plugs with the following configurations. Firstly, 120 volts, 15 amps, and secondly, 240 volts, 15 amps. It does not accept two-prong plugs with 20 amps. Modern NEMA configurations include grounding, which is essential for safety. Grounding provides a path for any electrical current that leaks from the device to be safely discharged into the ground. The current NEMA configuration for a non-grounding two-prong receptacle is NEMA 10-15R. It has two straight slots, one for the hot blade and one for the neutral blade. It accepts two-prong plugs with the following configuration: 120 volts, 15 amps. To ensure safety, it is important to use only receptacles and plugs that are compatible with the NEMA configurations for the electrical system. When dealing with electrical systems, it's crucial to understand the evolution and safety implications of different types of receptacles. The NEMA, or National Electrical Manufacturers Association, establishes standards for electrical connectors, including receptacles and plugs, in North America. These standards ensure compatibility and safety across various electrical devices and systems. Let's delve into the specifics of the old NEMA 10-15R receptacle and its comparison to modern standards. The NEMA 10-15R receptacle, which was prevalent in older buildings, is a duplex receptacle, meaning it features two outlets in one unit. It's characterized by its unique slot configuration, with two sideways T-shaped slots for the hot and neutral blades of a two-prong plug. One slot, intended for the neutral blade, is slightly smaller than the other. It's important to note that the NEMA 10-15R receptacle is a non-grounding type, lacking the third round or U-shaped slot for a ground connection. This lack of grounding is a significant safety concern in modern electrical systems. This receptacle was designed to accommodate specific voltage and amperage ratings. It could accept two-prong plugs with configurations of 120 volts, 15 amps, and 240 volts, 15 amps. However, it was not designed to handle two-prong plugs with a 20 amp rating. This limitation is crucial to understand to prevent overloading the receptacle and potentially causing a fire hazard. In contrast, modern NEMA configurations prioritize safety through grounding. Grounding provides a dedicated path for stray electrical current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, abbreviated GFCI, in the event of a fault. This protects people from electric shock and reduces the risk of electrical fires. The current NEMA configuration for a non-grounding two-prong receptacle is the NEMA 10-15R. This receptacle features two straight slots, one for the hot blade and one for the neutral blade. It's designed to accept two-prong plugs with a configuration of 120 volts, 15 amps. The absence of a ground connection in the NEMA 10-15R receptacle makes it less safe than grounded receptacles. Therefore, it's typically recommended to replace these receptacles with grounded versions whenever possible. There are several options for upgrading non-grounded receptacles to grounded ones. Firstly, if the wiring in the building includes a ground wire, the existing receptacle can be replaced with a grounded receptacle and the ground wire connected to the grounding terminal. Secondly, if there is no ground wire available, a GFCI protected receptacle can be installed. GFCI receptacles provide a level of protection against electric shock, even without a ground connection. Thirdly, another option is to install a new circuit with a ground wire, which is the safest and most recommended approach. When working with electrical systems, it's essential to follow all applicable electrical codes and regulations. The National Electrical Code, abbreviated NEC, provides comprehensive guidelines for safe electrical installations. It's also crucial to consult with a qualified electrician to ensure that any electrical work is performed correctly and safely. Ignoring or bypassing safety measures can have serious consequences, including electric shock, fire, and property damage. Therefore, it's always best to err on the side of caution and seek professional assistance when dealing with electrical systems. Furthermore, it's important to regularly inspect electrical receptacles and plugs for any signs of damage or wear. Cracked or broken receptacles should be replaced immediately. Loose or frayed wire should be repaired or replaced by a qualified electrician. Overloaded circuits can also pose a significant fire hazard. Avoid plugging too many devices into a single receptacle or extension cord. Use power strips with surge protection to protect sensitive electronic equipment from voltage spikes. Additionally, it's crucial to educate yourself and others about electrical safety. Teach children about the dangers of electricity and how to use electrical devices safely. Make sure everyone in the household knows where the circuit breaker panel is located and how to turn off the power in an emergency. By taking these precautions, you can significantly reduce the risk of electrical accidents and create a safer environment for yourself and others. Remember, electricity is a powerful force that should be treated with respect. Always follow safety guidelines and seek professional assistance when needed. In addition to understanding the differences between old and modern NEMA receptacle configurations, it's also important to be aware of the potential hazards associated with using adapters or converters. Adapters allow you to plug a device with a different plug configuration into a receptacle, while converters change the voltage of the electrical current. While adapters and converters can be useful in certain situations, they can also be dangerous if used improperly. Firstly, using an adapter to plug a device with a higher amperage rating into a receptacle with a lower amperage rating can overload the circuit and cause a fire. Secondly, using a converter to change the voltage of an electrical current can damage sensitive electronic equipment if the voltage is not properly matched. Thirdly, it's essential to carefully read the instructions and warnings that come with adapters and converters before using them. Furthermore, it's important to purchase adapters and converters from reputable manufacturers to ensure that they meet safety standards. Avoid using cheap or counterfeit adapters and converters, as they may not be properly designed or tested and could pose a safety risk. In addition to understanding NEMA receptacle configurations and the safe use of adapters and converters, it's also important to be aware of the different types of electrical cords and their appropriate uses. The electrical cords are designed to carry electrical current from a power source to an electrical device. They come in various sizes, lengths, and insulation types to suit different applications. Firstly, using the wrong type of electrical cord for a particular application can be dangerous. For example, using an indoor extension cord outdoors can expose the cord to moisture and damage the insulation, creating a shock hazard. Secondly, it's important to choose an electrical cord with the appropriate gauge or thickness for the amount of current it will be carrying. Using a cord with a gauge that is too small can cause the cord to overheat and potentially start a fire. Thirdly, it's also important to inspect electrical cords regularly for any signs of damage or wear. Cracked or frayed insulation, loose connections, or exposed wires can all pose a safety risk. Damaged electrical cords should be repaired or replaced immediately. Furthermore, it's important to avoid overloading electrical cords by plugging too many devices into a single cord or extension cord. Overloading an electrical cord can cause it to overheat and potentially start a fire. Use power strips with surge protection to protect sensitive electronic equipment from voltage spikes. In addition to understanding electrical cords and their safe use, it's also important to be aware of the potential hazards associated with water and electricity. Water is a good conductor of electricity, so contact with water can significantly increase the risk of electric shock. Firstly, never use electrical devices near water, such as in the bathroom or kitchen. Secondly, if an electrical device falls into water, do not touch it. Turn off the power at the circuit breaker panel and then carefully remove the device from the water. Thirdly, it's also important to avoid using extension cords in damp or wet locations. If you must use an extension cord in a damp or wet location, use a cord that is specifically designed for outdoor use and is labeled as such. Furthermore, it's important to install ground fault circuit interrupters, abbreviated GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect gram faults and quickly shut off the power to prevent electric shock. In addition to understanding the hazards of water and electricity, it's also important to be aware of the potential dangers associated with lightning. Lightning is a powerful electrical discharge that can cause serious damage and injury. Firstly, during a thunderstorm, seek shelter indoors in a sturdy building. Secondly, avoid using electrical devices, such as computers and telephones, during a thunderstorm. Thirdly, stay away from windows and doors during a thunderstorm. Furthermore, it's important to unplug sensitive electronic equipment during a thunderstorm to protect it from voltage surges caused by lightning strikes. Consider installing a whole house surge protector to protect your home's electrical system from lightning strikes. By taking these precautions, you can significantly reduce the risk of injury or damage from lightning. In addition to understanding the various electrical safety topics discussed above, it's also important to stay informed about the latest electrical codes and regulations. Electrical codes are constantly evolving to reflect new technologies and safety concerns. Stay up to date on the latest changes to the National Electrical Code, abbreviated NEC, and other applicable electrical codes. Consult with a qualified electrician to ensure that your electrical system is up to code and meets all safety requirements. Remember, electrical safety is an ongoing process. By staying informed and following safety guidelines, you can help to prevent electrical accidents and create a safer environment for yourself and others. Understanding the differences between old and modern NEMA receptacle configurations is just one aspect of electrical safety. By expanding your knowledge and awareness of electrical hazards, you can take proactive steps to protect yourself and your property from electrical accidents.